Okay, good morning student. Last time I have explained about the parametric function and derivative of parametric function. Today I will discuss more about that chapter. Some question I have done last time. Today I will discuss some complicated question, just like 7 question. Question number 7, that is given by in this way: x equal to this one and y equal to this one. So we have to find the derivative of this function, of parametric function. You can see that x is the function of t and y is also the function of t. So this type of function is called the parametric function. Means two variables are in the form of third variable. X and y are the dependent variable and t is the independent variable. So first do one by one. First take the x. So you know that we have to find out the dy by dx. How can we find the dy by dx? So first you find out the dy by dt and second defined by dx by dt. In this way you can find the dy by dx by dividing both derivatives. So let's come on first part, derivative of x with respect to t. So dx upon dt equal to, you can see that this is the quotient rule, derivative of quotient rule. What the quotient rule is? Denominator as it is derivative of the numerator minus numerator as it is in the derivative of denominator. Let's do by 1 under root cos 2t into ddx of sin cube t minus numerator as it is sin cube t into derivative of under root cos 2t upon square of the denominator, cos under root cos 2t whole square. Okay, now what can we do? Just do simplify. So under root cos 2t, under root cos 2t sin cube t, what will 3 sin square t into sin t. You can see that is the composite function. First you have to find out the, just like x raised to the power n. So 3 will come here and power reduce 1. Also sin t is another function for in the function of this one. So what the derivative of sin t with respect to t? Sin t is the cos t into cos t. Okay, this is all about this one. Now come to the next part. Sin cube t is as it is. Okay, and the derivative of cos 2t. So how can we find? Just like saying that under root x. What the derivative of under root x? You know that ddx of under root x. Okay, derivative of under root x, what will 1 by 2 root x. As you know, derivative of root x equal to 1 by 2 root x. So same as it is we have to do this one. So under root cos 2t means 1 upon 2 under root cos 2t. Okay, cos 2t into cos 2t is another function behind it. This is the form of this one, but cos 2t is also a function, another function. We have to find the derivative of this one by, you can say that, chain rule. So what that is? Cos 2t means minus sin 2t, or 2t is also, first I come this one, now come to this one, 2t is also a function, just by chain rule. What the value of 2t? That is the 2. You can see here 2, you can write here. Okay, now this 2 will be cancel out. So how can we do after this? Under root cos t means cos 2t. Okay, after this we can find the, just we have to simplify, just to cancel. Now take the LCM. This cos 2t will be reduced here, cos 2t into 3 sin square t cos t minus sin cube t minus will be plus sin cube t into sin 2t into sin 2t 2t upon cos 2t, or this LCM will come here, under root cos 2t. This is the all about dx upon dt. Is that clear? Okay, now come to the next part for y. Y part we can after this use same as we can find the second part. Now you can observe that y equal to dy by dt equal to just like this one, under root cos 2t into ddx of cos cube t minus cos cube t as it is into ddx of under root cos 2t upon under root cos 2t whole square. Okay, cos 2t whole square. In this way you can find. Okay, now simplify it. Cos 2t under root cos 2t, what will come? Same as this sin cube here, that is same here. So 3 cos square t into cos t minus sin t. Okay, minus cos cube t dx, you know, just like this one, cos 2t, just like you have to do. What will come? 1y into 1y 2 under root cos 2t, it cos 2t differential minus sin 2t into 2t, that will come in 2 into 2 by using chain rule. Cos 2t under root cos 2t, that's 1 over 2 root cos 2t, cos 2t differential minus sin 2t, 2t differential will 2 upon cos 2t will come square of this one. Now come to dy by dt. Again you can write. What will come? By taking the LCM, this will come, this 2 will cancel and this will come here. By taking the LCM, root will cancel out and will come cos 2t 3 cos square t, there will come here minus, also minus will put here, minus and sin t, or minus plus cos cube t sin 2t upon cos, sorry, yeah, you can write here in this way. This LCM will come downside, under root cos 2t into cos 2t. Okay, clear? Now we have to find out the dy by dx. You know that dy by dx means this upon this. Okay, you can write dy by dx. How can we find dy by dx? This upon, if we write this one, dy by dx, divide this one, minus cos of 2t 3 cos square t sin t plus cos cube t sin 2t, okay, upon this one, under root cos 2t or cos 2t. Okay, similarly you can write here dx by dt cos 2t 3 sin square t 3 sin square t cos t plus sin cube t into sin 2t upon under root cos 2t into cos 2t. This whole quantity will be cancelled out, and now put the value of this one. You can see dy by dx. Okay, so dy by dx equal to, after this we can write minus cos 2t 3 cos square t sin t plus cos cube t. You can open the identity cos 2t sin 2t into 2 sin t into cos t. You know that sin 2a, what the value of sin 2, identity of trigonometrical identity you have studied in 11th class. Sin 2t will 2 sin t into cos t, so we have to write here 2 sin t into cos t. Similarly in denominator we have to write cos 2t 3 sin square t cos t plus sin cube t. What the value sin 2t? 2 sin t into cos t. Okay, after this you have to write here. After this we can write, just we have to simplify. Observe that sin t cos t here, sin t cos t here, we can take out the common. Similarly for in denominator also, sin t cos t, sin t cos t. Why we put the sin 2t? Since sin t cos t here also, and the sin t cos t we can make here also, so we have opened this identity. Okay, now take the common in numerator and denominator both. So you can take out the common. Sin t cos t taken outside, what will remain here? Cos 2t minus cos 2t or 3 cos t, 3 cos t plus cos cube t, 2 cos cube t. Okay, similarly in the denominator also take the common sin t cos t here. What will come here? Sin t cos t, here will come cos 2t 3 sin t plus sin cube t will come here sin cube t, 2 sin cube t. Okay, in this way you can see that they will cancel out. What will come after this? So after that you can observe that we have to simplify. That is the simplify, or we have to more we have to simplify. So we have to put the value of cos 2t. So what value are suitable for here? How can we observe? You can see that here cos 2t identity with according to the cos cube, cos in terms of cos, so that we can take out the common or we can reduce in terms of cos. Here will be 2 sin cube, we have to put the value of cos t according to the sin cube t, so that we can reduce or cancel out. So put the value here. So minus 3 cos t and the value of cos 2t according to the this one cos in terms of, so what we 2 cos square t minus 1. Okay, plus 2 cos cube t. Similarly, in denominator also, cos 2t in terms of sine, cos 2t, first we write the 3 sin t, 3 sin t in bracket cos 2t, 1 minus 2 sin square t. Why we write different? According to this one, here is the cos, so that we can reduce or cancel out. Here is sin, so according to this we write this entry, so that we can reduce or cancel out. Plus 2 sin cube t. Okay, now multiply this bracket, 3 cos t, 6 minus 6 cos cube t plus 3 cos t plus 2 sin cube t. Is that clear? Okay, similarly for denominator also, multiply this one, 3 sin t minus 6 sin cube t plus 2 sin cube t. Okay, this is the, we reduce, there is no need to bracket. Okay, just simplify. You can observe these terms are same, so we can reduce. How much will come? Minus 4 cos cube t plus 3 cos t. Similarly in denominator also, this will simplify and reduce. How much come? 3 sin t minus 4 sin cube t. You can see that if we take out the minus common, there will come it 4 cos cube t minus 3 cos t upon 3 sin t minus 4 sin cube t. You know that this is the int. Which int will come here in the form of cos? This is the int of cos 3t. So minus cos 3t, this will go minus will here, and this is the int of cos 3t. Similarly, this int of sin 3t upon sin 3t, that will come minus cot 3t. Okay, this is all about the question number 7. In this way we have to observe and we have to simplify. Okay, this is the question number 7, and you have to do. If any problem you can ask me. Okay, those students who has not subscribed the channel, please subscribe the channel and press the bell icon, so that you can find the latest video randomly. Okay, just do and pause the video. You can note down. After that we come to the next question. We have to show this one. So how can we do this one? So you can observe that this is the exponential form. Exponential form means we have to take the log. Whenever you get the exponential form, you have to take the log to solve all this type of problem. So first you do simplify it. So first take the x equal to a raised to the power sin inverse t, and this square root, this power will come here 1 by 2, or you can take x equal to, now take the log both sides, or either you can say first you do this one, a raised to the power 1 by 2 sin inverse t. Okay, now take log both side, because this is the exponential form, so we can take the log and simplify it. So log x equal to log of a raised to the power 1 by 2, you can write here in this way, sin inverse t, or you can simplify log x equal to 1 by 2 sine inverse t into log a, and you can do in this way, log x equal to, this term and this term are constant, so we have to arrange in the same side. 1 by 2 log a sine inverse t. Okay, now we have to differentiate with respect to t both sides. What can we write? Differentiate both sides with respect to t. Log x 1 by x into dx by dt. Okay, log x, differential of log x 1 by x, and the differential of x with respect to t, so dx by dt. If in the RHS we come, this is the constant, there is no need 1 by 2 log a. Since this is the constant coefficient of derivative, so we have to write only the derivative of sine inverse t. So what will be the derivative? 1 upon under root 1 minus t square. Okay, this is the, so dx upon dt, you can write dx upon dt equal to x log a upon 2 under root 1 minus t square. Okay, this is the equation number you can do first. Similarly we have to do for y. Now take the y equal to a cos inverse t, and this root will come into the power 1 by 2, and y is also can write a raised to the 1 by 2 cos inverse t. Now take, okay, this is also a exponential form, so we can take log both sides. Take log both side, so log y equal to log a raised to the power 1 by 2 cos inverse t. Okay, now simplify that. Log y, this will come by using the property of log m raised to the power n. So what will come? You know that log of m raised to the power n, what the property, this one, n log m. So this property we have to use here, log m raised to the power n. So this whole quantity will come here. A 1 by 2 cos inverse t log a. This is a constant. Now log y, this constant will bring in same side, 1 by 2 log a cos inverse t. Okay, this is the constant coefficient of derivatives, so remove, there is no need to differentiate. We have to differentiate only cos inverse t with respect to t. So differentiate both sides with respect to t. Differentiate both sides with respect to t. So what we can write? Log y 1 upon y, and y derivative of y dy with respect to t, dy by dt equal to, this is the constant, there is no need to differentiation, log a, and cos inverse t, what the derivative? Minus 1 upon under root 1 minus t square. Okay, so bring the y here, dy by dt, you can write minus y log a upon 2 under root 1 minus t square, equation number 2. Now you can find the dy by dt. How can we write? Okay, now come. Now dy by dx means, first you have to write this one, dy by dt upon dx upon dt. Put the value of these two. So what the value is? Minus y log a upon under root 2 under root 1 minus t square, and dx by dt x log a upon 2 under root 1 minus t square. Okay, you can see that denominator is the same. This will cancel out. This is also cancelled out. So dy by dx equal to only minus y upon x. This is the solution. Is that clear? This is the question number 11. In this way you have to solve the parametric function, and we can find the derivative of the parametric function, this type of solution. So if any doubt, you can ask me by clicking on the subscribe by the remarks. Okay, this is all about the exercise 5.6. so remaining question you can do. I think those are remaining question are easy comparatively to these two one, so you can do easily. If someone has any problem, you can ask me. Okay, now after this we have to come to the next chapter, next exercise, that is the second order derivative.